Welcome to Misconceptions and Difficult Concepts in Chemistry. Today's video will be touching on inter and intramolecular bonding. Inter and intramolecular bonding. So let's take, for example, chlorine gas. Boiling point minus 34 degrees Celsius. So why does chlorine gas have such a low boiling point compared to the other substances? So to boil chlorine, boiling point means to change from liquid state to gaseous state. So this is a liquid. To change this into a gas, you will need to overcome the bonding, the attractive forces between the molecules. So inter and intra comes about here. So chlorine is Cl2. Let's represent chlorine with two circles joined together. So this is one single chlorine molecule. So in liquid chlorine, for example, there would be many of these chlorine molecules. Okay. So in order for us to boil chlorine, to convert this from a liquid to a gas, we are overcoming the attractive forces between the molecules. Take note, the chlorine molecule is held together by strong covalent bonds. By a strong covalent bond. This is a single covalent bond. Chlorine has 7 valence electrons, so they share 1 valence electron each to allow it to form a stable octet configuration. So this is a single covalent bond. When we boil chlorine, when we convert this from liquid to gas, we are overcoming the intermolecular bonding. So this is the intermolecular bonding between chlorine molecules, and we know of this as van der Waals forces. Or sometimes it is also known as simply known as intermolecular attractive force. For O levels, you can still use intermolecular attractive forces of attraction or intermolecular attractive forces. But van der Waals forces is actually a more precise and accurate term. So to allow the chlorine molecules to move apart, we have to overcome the intermolecular forces, which is the van der Waals forces. We do not break the intramolecular forces. So this is one of the most common mistakes made by students when answering questions. They will state to break intramolecular forces, which is wrong, because the intramolecular force is this covalent bond, which is actually very strong. Okay, boiling point does not involve breaking of this single covalent bond. It involves the breaking of the intermolecular forces, which is van der Waals forces. Welcome to Misconceptions and Difficult Concepts in Chemistry. Today we will be approaching these two terms which are most commonly used by students when they describe substances, molecules, and compounds. So is a molecule a compound? Is a compound a molecule? Are they the same term? Can they be used interchangeably? The answer is no. So let's define molecules first. Molecules are used only for non-metal compounds. So if I can say a molecule of chlorine, this is a molecule of chlorine gas, Cl2, this is correct. I cannot say a molecule of sodium chloride, for example. This is an ionic compound, and I cannot use the term molecule. So this is only used for non-metals. A compound is a substance which is made up of two or more elements chemically combined together. So, for example, NaCl, two elements chemically combined together. I can say that this is a compound. Compound is correct. Molecule is wrong. So this is not a molecule. This is a compound. Can I say that chlorine Cl2 over here is a compound? No, I can't say that because it is only made of one single element, except that there are now two chlorine atoms chemically combined together. I still call this a chlorine molecule. It is still called an element. Okay, element. It's still called an element. It is not a compound. It is an element in the molecule form, Cl2, diatomic molecule. Can I say a molecule of iron? A molecule of iron, is this correct? Nope, it is not correct. Why? Simply because iron is not a non-metal. Alright, so if I have Fe2O3, iron 3 oxide, can I say this is a molecule of iron 3 oxide? No, because iron 3 oxide is an ionic compound. I can say that iron 3 oxide is an ionic compound, but I cannot say that this is a molecule. Okay, so do not confuse between the terms molecules and compounds.